Hello class, and welcome to section 9.8, which is about quadratic functions. By the end of this lesson, you will know what a quadratic function is, and you will be able to graph them and use them to solve some basic problems. So a quadratic function is the first type of nonlinear function that we are going to look at. A quadratic function is a function that is written in the form y equals ax squared plus bx plus c, where a does not equal 0. So this equal with the slash through it means does not equal. In order to be a quadratic function, it has to have an x squared somewhere in the function. So it could be a function as simple as saying y equals x squared. That's the most basic quadratic function. Or it could look like y equals 3x squared plus 2. And it can leave out that middle part, or it could say y equals 1/2 x squared plus 4x, and it could leave out that c part, or it could be the complete equation and have something like 7x squared minus 8x plus 1. So it can be in many different formats, but if you notice, the consistent part through all of them is that it has that x squared piece. The term parabola is what we use for the shape of the quadratic function. So it's this curved U shape. Some of the U's are going to be going up like a normal U. Some of the U's that you're going to see are going to be turned upside down. But all of them have this curved shape that we call a parabola. So our first goal with quadratic functions is just to be able to graph them. We're just going to be dealing with very basic quadratics today. Next year in algebra, we'll get into much more in depth, but I just want to give you the basics. So in order to graph, you're going to make an XY table, and you are always going to plug in -2, -1, 0, 1, and 2 into your table this year. Again, in 8th grade, we're going to get into the more complex ones, and you're going to use different values to plug in, but for now, for our purposes for this lesson, it's always going to be -2, -1, 0, 1, and 2 for x. So in order to solve the first part, you would plug into your calculator and you would say, you obviously don't type in the y equals, so you would put in -2, remember that has to be in parentheses, caret squared minus 2. And that's going to give you a value of when you plug that in. That's going to give you a value of 2. Then you would go ahead and change that -2 to a -1. When you do that, you're going to get an answer of -1. Then you're going to turn it into 0, and that's going to give you an answer of -2. Then you're going to turn it into +1, and that's going to give you a -1. And then you're going to turn it into +2, and that's going to give you an answer of 2. So then we're going to come over to our graph, and we're going to go x is -2, so 2 left, and then up 2. And then we're going to go -1 and -1. And then we're going to go 0, -2, 1, -1, and 2, +2. So you get this curved parabola shape. It's going to be a little bit difficult for me to draw in that curve. It's a little difficult when I'm using this pen, but I will try my best. The one thing I want to make sure that you guys are doing is curving it as you are going through. Again, like I said, these are kind of difficult to draw, so I apologize for the lack of accuracy. Again, it has to be curved down here. If I see your graphs coming to a point like this, that will be marked as incorrect. The graphs that come to a point are a different type of graph called absolute value graphs, so it has to come to a curve here. Again, it's going to be kind of difficult to get used to drawing these curves. You can see I even am a little off as I am drawing them, but the key feature is that it is curved here at the bottom. I'm going to have you try graphing this one on your own. Notice that it's y equals -x squared, which means your equation actually is y equals -1 times x squared. So go ahead and make the table. Try it on your own. So we've got, when we plug it in, we end up with -4, -1, 0, -1, and -4. So we end up with this parabola shown on the graph. So that's the basics of graphing. Now we're going to get into a couple of the basics of using these equations. So, for example, Mel is making a rectangular picture frame. The width of the frame is x inches, and the height will be 2.5x inches. Our first job is to write and graph the equation for the area. So we know that the area of a rectangle is equal to the base times the height. So I'm looking at my values here, and I know that my values are going to be area is equal to x times 2.5x squared. We learned earlier in the chapter that when we multiply, we need to add our exponents. So I've got 1x and 1x. So that's going to give me area is equal to 2.5x squared. So that's the equation that you're going to be using. Then you're going to need to go ahead and make your table. So we've got our x values and our y values. Now, I know I said to start with -2. When you are looking at word problems, you need to decide if you can go into the negative numbers. In this case, our x stands for the width of a picture frame. We can't have a width of -2, so we're going to start at 0, because even though we can't have a 0 width within a picture frame, when I plug in 0, 0 squared times 2.5, 0 is going to give me a starting point for my graph. So with this word problem, if the negatives don't work, you are going to always start with 0. Then you need another 4 numbers, so 1, 2, 3, and 4 is what we're going to plug in here. So when I plug in 1, I'm going to get an answer of 2.5. When I plug in 2, I'm going to get an answer of 10. When I plug in 3, I'm going to get an answer of 22.5. And when I plug in 4, I'm going to get an answer of 40. So those are the answers I get when I plug in. Now, I need to be able to fit these numbers onto the graph, and I need to be able to go up to 40. So I'm going to go ahead and I'm going to count by 4s. So I'm going to go 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. So now I need to plot these points. So I'm going to go ahead and start with 0, 0. Then I've got 1, 2.5, so that's going to be somewhere in the middle here. 2, 10 is going to be right in the middle of 8 and 12. 3, 22.5, so that's going to be in the middle of 20 and 24. And then 4, 40. So you can see right now we only have half of that curve, which is completely fine. That other half would be if we were allowed to have negative widths, but we're not, so we only have half of the curve right now. Now for the second part, it says how long will the width need to be if the area of the frame is going to be 70 inches. So this y value is our area. So far we're only up to 40. So what that means to answer the question is I'm going to have to keep going. So I'm going to plug in now x is equal to 5. And when I do that, I get an answer of 62.5. That's not 70 yet, so I'm going to plug in 6, and I get an answer of 90. That's too big. So what we're going to say then for our final answer here is that the width is between 5 inches and 6 inches, because our answer for the area went from 62.5 to 90, so somewhere in there is 70. And then we're going to say that it's closer to 5 inches, because 62.5 is closer to 70 than 90. So it's somewhere between 5 and 6 inches, and it's going to be closer to 5 inches. Another problem, we got Matt is building a rectangular vegetable garden. He wants the width to be x and the height to be 10 minus x. So we're going to start by writing and then graphing the equation. So I'm going to help you with the writing part. So we've got area is equal to our base, which is x, times our height, which is x minus 10. Now notice, there's parentheses here, so this is going to become a distributive property. So I've got area is equal to 10x, 10 times x, minus x times x, which is x squared. So that's how we get that quadratic, that's how we get that square in there. I want you to go ahead and make the table starting at 0 and then graph it on your own. So when we do that, we're going to end up with that blue table, and then we've got our blue graphed points so far. I counted by 3s. If you counted by something else, your graph might look a little different at this point. Now our job is going to be to find the maximum area of the garden. So notice, my curve is curving up right now, and we're trying to figure out what that top point is. So I want you to extend that table, starting with 5 and continuing to go, until you get to the highest possible area value, the highest possible y value, and type that in as you try this one on your own. So when you keep that table going, you find that when you hit x equals 5, you go up to 25, and then when you plug in 6, it's going back down to 24. So we're getting that downward part of the curve now on this one, which means your maximum area is going to be 25 feet squared. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.